So in moment and kurtosis, we said, that is in skewness and kurtosis. Skewness, we said it is departure from symmetry, okay, lack of symmetry, and we have it in three types. We either have the negatively skewed one, where the tail is longer to the left, or we have the positively skewed one, where the tail is longer to the right, or we have the normal one, that is the normal curve. So skewness will occur when these measures or this distribution deviates from the normal. This is the normal one, or the symmetrical one if you want. This one is symmetrical. This one is skewed, which is negatively skewed. This is negatively skewed, and this one is positively skewed. And we said you can find out this one by comparing the size of the mean and the mode. So like in this one, x bar will be less than the mode, and the median will be somewhere in between. For this one, x bar will be greater than the mode. We have the measures of skewness. We had the Karl-Pearson's coefficient of skewness, Karl-Pearson's coefficient of skewness, which either relates the mean, the mode, and the standard deviation, or the mean, the median, and the standard deviation. So for example, the first one is x bar minus mode divided by the standard deviation. So if I have the mean, the mode, the standard deviation, I can calculate the Karl-Pearson's coefficient of skewness, and I'll be able to interpret this to know whether it's negatively, positively skewed, or symmetrical by looking at the sign. So when the answer here is negative, then you know it's negatively skewed. Positive, positively skewed. A 0 will mean it is symmetrical. Number 2, we had the others, the Boris, the carries, but here I'm only going to recap the moment's coefficient of skewness. Moment's coefficient of skewness. And this one we said it's given by what? The third central moment, I'm writing it in words, divided by third central moment, divided by second central moment, and you raise this to power 3 over 2. So this is the same as m3 divided by m2 raised to power 3 over 2. So when you calculate that, you're able to get the moment's coefficient of skewness. Good. What about kurtosis? Kurtosis, we said it's the degree of flatness or opacedness allowed the region allowed the mode of a frequency distribution. Now the kurtosis, the moment coefficient of kurtosis, it makes use of moment coefficient of kurtosis makes use of the fourth central moment and the second central moment. So this is usually given by m4 divided by m2 raised to power 2. So we can look at a simple example here. Suppose in this example we are given that the first central, the moment about an arbitrary point, because I want to start from there, that the first 4 moments about an arbitrary point is equals to 5. The moments are given as, if you can call it m1 prime is given as 2, m2 prime is given as 20, m3 prime is given as 40, and m4 prime is given as 50. So suppose I want to calculate the mean from this information, that is x bar. We've just said by definition, this one you use the formula for calculating arithmetic mean using assumed mean method. It is a plus summation d over n, which is the same as a plus the first moment about an arbitrary point. Our arbitrary point here is 5. The first moment about a is 2. So the answer becomes 7. Simple. What about the standard deviation? We know this is the square root of the variance. And what is the variance? We know the variance from our previous concept is actually the second central moment. So it is actually the square root of m2 prime minus m1 prime squared, which is equals to what? Which is equals to 20 minus 2 squared. And that is equivalent to 20 minus 4, the square root of that, because we are looking for the standard deviation, which is equals to the square root of 16, and that is equals to 4. Answered. Now, suppose I want to calculate the moment coefficient of kurtosis, of skewness, moment coefficient of skewness. It means I'll need to compute, according to the formula, this one, I'll need to compute my M3, which we've said in our previous knowledge is equivalent to M3 prime minus 3 M2 prime M1 prime plus 2 M1 prime squared. So we substitute this. So we need to just substitute our third one, which is 40, minus 3 times the second one, which is 20, times the first one, which is 2, plus this one should be 2. Sorry, this bracket here should just be here. It is this one that is raised to power 2. So 2 times the first one, which is 2, squared. So simplify this. When you simplify this, you get a third moment. Now, after getting the third central moment, you come and substitute it in your formula here. Then you'll be able to get the moment coefficient of skewness. And then you interpret the way we've said you're supposed to interpret. If it's negative, you get a negatively skewed distribution. Positive, positively skewed distribution. And then if it is 0, you get a symmetrical distributed distribution. So we are saying here, it is easy to compute this one if you know the formulas relating the central moment and moments about an arbitrary point. So similarly, you can go ahead and use the same values that I've given you here to compute M4, okay, using the formula. Then you come and substitute your form for M4 in. And the second moment, of course, remember our second moment here is actually the standard, the variance. Our second moment is this one, which is the variance. So you come and substitute them in the formula for the kurtosis, and then you interpret. And we said for the kurtosis, what? When the moment coefficient of kurtosis is less than 3, then you have a praticatic distribution. If it is greater than 3, you have a reptochatic. If it is equals to 3, then we said in that case, you have a symmetrical distribution. So basically, that's just a quick recap on skewness and kurtosis and the moments or the measure of kurtosis and skewness using the moment, because it's application of moment. And thank you very much. Just try to go through our notes, the class note, the lecture note, and the examples that are given therein together with these examples, and you will be comfortable even when answering any question on moment, skewness, and kurtosis. Follow up my next video on a recap on probability. Thank you.